functions are we dealing with? Polar. And with polar, we wrote down a number yesterday that had two different things on it, and we're going to use both today. One of them is area between, and the other one is area inside both. One of them is area between, and one of them is area inside both. One big thing to remember is outer radius, inner radius. When we're doing between, we need to figure out the outer and subtract his area with our formula. Or no, do take that his area with our formula minus the inner radius. We're going to draw some pictures today. Hopefully it makes sense. And then inside both, outer, inner doesn't really matter because we're just adding the two. All right, we're going here to example number 5. Why was it good to find intersections? Why was it good to find intersections? Because we needed to find bounds. Now guys, why didn't we go from pi over 2 to 3 pi over 2? Why not? Why not pi over 2 to 3 pi over 2? Because those were intersections, right? Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2.
Because it's
Okay.
parallel.
Because what? No. Good idea. That's not why though. Why not? Let's look back real quick. I didn't explain it super well yesterday because I was going fast. But let's go back. What's the very, very bottom one say? Watch the movement. Guys, in your calculators, can you throw these two into your calculators really quickly? Not to say that you necessarily can always use your calculators, but I want you to throw these two functions in. Couple things first. I need you in radian mode, polar mode, simultaneous mode. I need you in radian mode, polar mode, and simultaneous mode, simul. I need you in simul mode, okay? Then we're going to plug in our two different polar equations. And I have the little circle with the little line. The little circle with the little line. I have r equals 1, and I have r equals, what's the other one? 1 minus cosine theta. 1 minus cosine theta. I'm going to get a big graph out. Okay. When you graph, when you hit the graph button, you can pause it by hitting enter. You can pause it by hitting enter, okay? I'm going to graph. I'm going to do zoom standard because that's lame. I can't see it very good. Hold on. Okay, hold on. Zoom in. Okay, better. Are they going to intersect? Uh-huh. What angle is that? Yeah, how come? Because the graph is moving from 0 to pi over 2, and it's moving to pi, moving to 3 pi over 2, moving. Did it intersect again? Uh-huh. It did pi over 2, and then it came around 3 pi over 2. I know that. The math told me that. So why don't I just put it in the bounds? Then it finishes. Every graph doesn't behave the same way. We saw sometimes they move faster, sometimes they move slower, sometimes period only 0 to pi, sometimes period 0 to 2 pi. But wait. What does integral do? If I start at pi over 2, to 3 pi over 2, first of all, for this graph, starting at 3 pi over 2, I'm starting here and I'm saying, oh, go. It goes from the pole out to the graph, go, to 3 pi over 2. If I go from pi over 2 to 3 pi over 2 in the other one, I'm saying, go, whoa. Guys, if I subtract those two, what am I finding? That?
No.
I'm finding this.
Mm-hmm.
Is that helpful?
No.
Is it area between? Yes, but the wrong one. So I'm not doing pi over 2 to 3 pi over 2 because then zoom, wrong area, total wrong area. So therefore, I don't want to do pi over 2 to 3 pi over 2. Instead, I want to do, well, okay, there is pi over 2, but question, guys, can you tell that's the end? I want to go backwards from pi over 2, and if I go backwards from pi over 2, well, when am I going to stop? Negative pi over 2. So I'm going backwards. I'm going pi over 2 to 0, and then I'm going to negative pi over 2 of the one curve, and then I'm subtracting the other curve. And if I take one minus the other, what am I going to get? The in-between. The in-between. But there are two ways to do it. I could, because polar graphs are usually symmetric, symmetric. Since they're symmetric, I could go negative pi over 2 to pi over 2, or I could go,
0.
I'll do this, or I could go just 0 to pi over 2 and do what? Times 2. Why might that be easier? I don't know, maybe easier to plug in. You can either go from 0 to pi over 2 times 2, or you can go from negative pi over 2 to pi over 2 regular. And that's where I get work on the other page. Melissa?
Do you know when you know how when you have a normal graph and you take the integral, anything below the x-axis is negative, like considered negative area, so you subtract that? Is that the same?
Don't have to worry in polar, because polar you're always going from pole out to curve.
Okay.
The only time you would have something other than a positive number is if it's at the pole, like from the pole to the pole, and it'd be 0.
Okay.
But no such thing as negative. Good question. Let's go back to this then. Does it make sense what I did? I went from negative pi over 2 to pi over 2 of, why did I choose 1 first? Why 1 squared minus 1 minus cosine squared?
Because that's the first function.
Which one's outer? Which one's outer? So if we think about our formula, and guys, we can actually make our formula a little bit simpler. We could theoretically say 1/2, and this is only if the bounds are the same, but we could make it, you know what, bounds aren't always the same. Let me not even show that to you. But we could say r1 squared d theta minus 1/2. I'm just going to leave it separate because they're not always the same. Pi over 2 to pi over 2. Remember, this one being the outer. Why outer? Because you have to go out further to it. And this one being the... Does that make sense, kind of? So I do 1 first. Why? Because radius of 1 is just circle. Circle, out 1, out 1, out 1, out 1, out 1. This one is out more. That one's in.
So if you write it in the other way, it's just integral of pi over 2 to 0, 1 squared d theta minus integral of pi over 2 to 0, 1 minus cosine.
Because you would have 2 times 1/2, which would go away. Good. Good. All right, are we okay, guys? Can I just say solve, solve, solve? And I'm just going to put at the very end, in case you want to go and make sure by hand you're okay, 2 minus pi over 4 would be the final answer. Okay? Can we go to example number 6? Oh, number 7. Do I want number 7? Oh, I do want number 7. Because we already did 6, because he was an easy one. At least comparatively. Oh. Okay. Find the area in the second quadrant enclosed by the coordinate axis and the graph of f. What am I supposed to do, kiddos?
Area in the second quadrant. So just from pi over 2 to pi. There's that. That's not second quadrant.
How do you know?
Well, so it's enclosed by second quadrant.
Mm-hmm.
And that is the second one.
Second quadrant?
Which one's second quadrant? I forget.
It's...
Yeah.
They want that area,
Yeah.
right?
So isn't that pi over 2 to pi?
Yeah. And I said 0 to pi over 2. That was my bad. Now, if you were worried and thought, oh, maybe this is working differently than I think, what could you do?
Check on the calculator.
You could check on the calculator, or you could graph by hand and make sure, like, at 90 degrees. Huh! They didn't even give it to me. Did they give me the function?
No.
They didn't at all? I have a function written down, but I don't know why.
You need to have the graph.
Yeah.
Okay. They didn't give you the problem. Hold on. I have the problem. Somehow it got messed up. Polar curve. Write this down, guys. given by r equals 3 theta plus, thank you for letting me know, otherwise we would have all been confused, for theta between, there we go. So much more sense. So much more sense. So this one is going to behave normally because 0 to 2 pi is just going, you guys can see it going, right? You can see how it would move. It's a spiral, starts in the inside, goes on the outside. Each angle goes, goes, goes. If I was to plug in, you could double check if I was to plug in 90 or pi over 2. I have 3 pi over 2 plus sine of pi over 2, 1, right? So 3 pi over 2, 3 pi over 2 plus 1. It's going to be a positive number, and you can think as I keep on adding and adding and adding, sure, sine is going to cycle between 1 and negative 1, but I'm multiplying by more and more powers of 3, and 3 will always be greater than sine, so then it's going to keep on going out, 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 etc. So, therefore, all I need to do is plug in pi over 2 to pi of, we'll just say r of theta squared, right? D theta.
That's it?
Mm-hmm. Then we plug it in, plug and chug, and we end up with 47. Wait a minute, how are we able to plug and chug this in our calculator? There's thetas, not x's. What do we do?
We're in polar mode.
Well, we are in polar mode, but what else? Can I do integrals in polar mode?
Yes.
Uh-huh. So I can go, for instance, hold on, let me throw in my calculator really quickly. What do we have? 3 theta. 3 theta plus, oops, that's not going to work. 3 theta plus just sine?
Sine
Good, good. And I know from 0 to 2 pi, where did you go? Come back. So then I would go to my window, right? And I could have my theta min 0 to 2 pi. Psh, I'm good, I'm done. And I can go ahead and, oh my goodness, stop moving. It's being difficult. Stop. Okay. Then I can graph. Graphity graph, 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 graph. I'm going to go ahead and pause, zoom out. Graphity graph, 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 graph,
Why
graph,
is
graph,
it
graph.
from pi over 2 to pi again?
Because second quadrant, what angles form the second quadrant? It's going 0 to 90 right now, and then it's going 90 to 180 just because that's the nature of the graph.
Is it like
Second quadrant's
going
here.
on the x?
So it's
Or
going like this. So as I have 0, 45, it's going out, out.
Okay,
Remember, this
got
is
it.
polar. Does that make sense? Is there an integral? Huh.
What did you?
I can't take integral. So what do I need to do? Back here, old-fashioned way. What do I do if I have thetas? I'm just double-checking because Calc AB got confused on this last test, and I didn't mean for them to. What would I do?
pi over 2?
What variable would I do it in?
You still press it, it gives you
Why is it?
Yeah, I can just use my variable button. And if for any reason it was a different variable, guys, does it really matter? As long as I put a variable in, doesn't really matter. It's going to solve the exact same way. Youngji, what were you saying, kiddo?
Why is it negative pi over 2?
Oh, thank you. Not negative. It's positive. I was thinking about last example, how it was negative to positive. I know, huh? Crazy. Hold on, we have to square this. Don't forget. So we have our 3 theta plus sine of theta. Stop it. Square it. D theta. Got it, go. Wait, what's wrong? A, I typed it in wrong. That's a good start. And B, we still have to do times 1/2. So we could do 1/2 times the integral. But I did type it in wrong. That was my bad. I know. Anyway, we're good on plugging in, right, guys? We like plugging in. We like problems that let us plug in. I'm just making sure I'm right, though. Now I'm good. D theta. Ta-da! 47.513 done. Okay, cool. We like that. How about B? What's going on? 4. There's our graph. 4. Pi over 2 less than or equal to theta less than or equal to pi. There is 1 point P on the polar curve with x coordinate -3. Ugh. Find the angle theta that corresponds to point P. Find the y-coordinate of P. Show the work that leads to your answers. Well, how do I even? I don't understand. I don't want to give everything away right now. What do you guys think I can do? X-coordinate. Wait, I don't see any x's. Do you see any x's?
No.
But what can we do?
Plug it in.
Plug it into what?
X equal to
X equals. Do you guys have this one memorized yet? X equals what?
y cosine
R, and what's R? 3 theta plus sine theta. Cosine theta, right? There's one point P on the polar curve R with x coordinate -3. Uh-oh, and you set all of this equal to -3? No way. If they ask me to do that by hand, I am going to, guess what? Calculator.
Do it by hand.
Nope, we don't have to. This is a calculator problem. Hence why I did decimals in the answer before. Find the angle that corresponds to point P. Find the y-coordinate of point P. Show the work that leads to your answers. Kiddos, hold on. How do I solve a nasty equation equal to a number?
Inverse trig.
Inverse trig?
I know.
But I have sine times cosine. Can I get theta by itself? Mm-mm. But what can I do?
intersect.
Can I graph and find intersect? Yay! Let's graph. Hold on, pause. Make sure we can. Can we do intersect in this mode?
Yes.
I don't see intersect.
Oh, so you just.
So we're going to change back to function mode and say, whatever, function mode lets me do intersections, so I'm going to go back and do intersections in function mode. How? Plug and chug. Plug and chug what? Whatever. Make the thetas into x's. So just take him, y equals. Function mode at least lets me solve for intersections. So just because it's a polar problem doesn't mean that there's no point in going back, because I want to find that intersection. I can't do it by hand, but my calculator can. Now, hold on. Do I have any guideline as to where to look? Oh yeah, pi over 2 to pi, and that's my range of thetas. And what are my thetas standing for right now? Or what is representing thetas? X's. So I'm going to make my x's go from pi over 2 to pi. Just so I know where I'm looking. And hopefully there's an intersection. Uh-oh, what did I do wrong? Go to. Oh, too many. Too many parentheses. Booyah. Got it. Does that make sense?
Yeah.
So polar is great. Polar lets me know what it actually looks like, but function mode says, okay, I'm not going to graph it the right way, but I do know when they're the same. And I can find that because you can use in function mode the intersect feature. And I think I already got it. There it is. The intersection ends up being, hold on, careful. I plug in essence, I'm making this y1, and in essence, I'm making theta equal to x. So over here, when I'm solving, you have to be careful. The x is a theta, and the y is an x. Oh, that's gross. I know, but it makes it possible. And we can't go changing in function mode what variables are. So then I can say, okay, x is going to equal -3 when theta equals 2.01692, whatever, 34. Blah. It says find the angle. All right, cool. Then what does it say? Find the y-coordinate. How do I do that? Is that the y-coordinate? No. Y equals r sine theta. Good.
Misty,
Yeah.
for those questions, may I use magnitude integral in function mode? I think it's still.
You technically can, but problem is to do in function mode, I don't know what the purpose would be. Do you mean graph or do you mean just normal from home screen?
Just figured out the answer.
Like with x's instead of with thetas back here?
Yeah.
Yeah, it'll be fine.
Okay.
But the graph, I wouldn't do the graph because you have to take one squared minus the other one squared. I'm not going to graph that.
Yeah, it does.
Yeah. Yeah. So not from graph, but yeah, from home screen, you can be in any mode and it'll just say unknown, unknown, solve, and it solves it the same every time. Yeah, solves it the same every time. That's why we have to have different formulas for polar, because otherwise integral does the same thing and we need it to work a different way. Kiddos, if we go ahead and plug in, he died. Shock horror. I have to rejuvenate him. If we plug in Chug, we will get our Y value. Now hold on, part C is a little bit more interesting, right?
Yes.
All right, let me give you a second to read it, because we have to start with reading. We have to start with reading.
You could just write numbers down low.
Just randomly write numbers down, just for the heck of it?
Yeah.
That sounds like fun. No, does not sound like fun at all.
Just reading sounds. Yeah, I don't know what this means.
It's okay, we got this. No one plugged in Chug, did they? Where's my calculator? Is this distraction?
I got it.
Okay, what'd you get?
6.27238006.
2753, we'll just stop there.
2723.
Ah, 23, sorry. Better. Haha. Burp. And burp. Done.
I think I'm just coming for your class tomorrow.
What?
I think I'm just
Okay.
coming for fourth grade.
A particle is traveling along the polar curve. Ooh, we have somebody moving on it. Okay, so that's position at time t is, and such that d theta dt is, find dy dt at the instant that, and interpret the meaning of your answer in the context of the problem.
That was 3
Wait.
different-
We don't have anything?
We have stuff.
Yeah, we have.
What do we have? Hold on, what are my variables? What do we see? We see x, we see y, but wait. What do they give us? Theta, t, y, theta. Hold on, what equation has theta and y and t? What has theta and y? Didn't we just write it down a second ago? So wait, we can say y is equal to 3 theta plus sine theta times sine theta. T. Oh, implicit differentiation. Just take dTdt. It's like a AB question. Just with a little bit more complicated wording. What do we do? I don't know. Derive. Derive us crazy. dy dt. Keep going. What else?
3 sine theta plus cosine.
3 plus cosine theta? Right?
Oh, you're doing it like that. I distributed the sine theta to each.
Oh, got it. So derivative of the first would be 3 plus cosine theta times d theta dt times the second. Plus derivative of the second would be cosine theta d theta dt times the first. The only reason I didn't list those is because then I have two product rules and I was like, ugh. But you could. Now what? Plug it in, how? You plug it in, right?
Yes.
So then I know what? D theta dt. Okay, cool. D theta dt is 2. D theta dt is 2. And I know my such that theta is equal to 2 pi over 3. Right? Psh, I'm just plugging and chugging. Wait, wasn't this a calculator problem? So what can we do? Plug it in. As long as we're in radian mode, we will be good to go, and I am, so we can do 3 plus cosine of 2 pi over 3. You guys can double check me, because I'm just kind of going. Times 2 plus sine of 2 pi over 3. Plus cosine of 2 pi over 3 times 2 times 3, 2 pi over 3 plus sine, oh my goodness, 2 pi over 3. Please let me be right. Anybody with me?
Misty,
I get negative 2.819.
can you not plug it in? Oh, no, you can't.
Because if you do and take the derivative, it's 0. Wait, what? No.
No,
You're saying that his speed is constant. I have to say that it's changing. It's very,
I get negative 2.81.
yes! Youngji, you and I match. So we have dy dt such that theta is equal to 2 pi over 3 equals negative 2.819. Wait, interpret. Stink. Wait. Think. Interpret the meaning of your answer in the context of the problem. A rate is negative. A rate of y's changing with respect to t is negative. I can think velocity is negative because it's a particle moving, so that's velocity. Velocity in the what direction?
Wider.
In the y direction. So velocity in the y direction is doing what? Wait. Velocity is negative, which means
That the
position
is the function
in the y direction is decreasing. Wait, how can I put that prettily?
Can use symbols.
I don't know if you need to put it prettily. Do I just put it unprettily?
Yeah.
Hold on, let me get rid of this little screen shade. He's in my way. I can't go down anymore.
Really a word.
Prettily? I don't know. I just made it up. There you have 2. Oh, look, I had it off to the side. We're right. Ta-da!
Since
Oh my goodness, we could have taken a derivative in our calculator and not had to do it by hand? How could we have done that?
Misty.
How could we have done that?
Go to math.
Because d theta dt could have been at the very, very end, and I could have just said, hey, take the derivative at such that I'm doing 2 pi over 3, and then I could say times 2 for d theta dt. But did our way work? Yes, it does. I'm just trying to save time. Interpret. We could say that the particle position is vertically decreasing with respect to time at something. Basically, it's fallen. It's a long story short. Do they give me any units? They don't, do they? So it's vertically decreasing, it's falling? I don't know, I guess you could say falling. But I like the vertically just because we're saying it's in terms of y. Layla, go ahead.
Is this like a type of FRQ that you ask?
Mm-hmm. And here's another way, guys. I forgot. I haven't done these FRQs in a while. We could say vertically decreasing. Let me give you a few other ways that the AP guys will put it. Vertically decreasing, we could say something like, let me take this, go off to the side. Heights are decreasing. Another way of saying it is that we could say at 2 pi over 3. Where would that be here? At 2 pi over 3 would be here. We're talking about, in essence, slope of the tangent line. We could say also the particle is getting closer to the x-axis. Anyway, whatever. probably spend too much time on AP stuff, but they use all of those, and we'll see this more. Not that the necessarily, like you have to have the wording completely perfect, it just needs to mean the same thing. Heights are decreasing, vertically decreasing, particles getting closer to the x-axis because it's falling, it's going down. Lots of different ways you can say it. Let's stop here. Example 8. What's different? The word inside, that means inside both. Ethan, here's the one we were talking about. Inside both. I have the graphs of the polar curves. We're going to stop here. The graphs of the polar curves, r equals 2 and r equals 3 plus 2 cosine intersect when, oh, they even gave it to me. Nice. Let r be the region that is inside r equals 2 and also inside. Okay, so that's the key. Excuse me. Inside, also inside. So, in our forever card, if we go back really quickly, or our endeavor card, sorry.
That's messy.
Silly allergies. Inside both. Let me show you what we're going to do and why we're going to do. You can look at your endeavor card and say, plus, what? Come over here. Okay. Inside both. Can you guys see what region is inside both?
Yes.
Yeah.
Right here, right? Here's the problem. I need a better picture. It's okay though, I'll show. Alright, here's the main idea. If I was to do 2 different colors, ready? First of all, we know our intersection is at 2 pi over 3 and at 4 pi over 3. Now technically what we should test is to make sure these are true intersections, but they told us so we can just use it, okay? They told us so we can use it. We'll find some funky ones when we're doing AP review where you have to double check what you think are the intersections, but anyway. Okay, here's the idea. If I was just to, first of all, let's just think about bounds. Let's just think about bounds, okay? We know that we want this region inside. I'm going to do a quick highlighting thing because I don't want to make it super dark. Highlighting, 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 highlighting this one. Okay. All right. If I was thinking about bounds, I know you can barely see it, but that's on purpose. If I was just thinking about bounds, question, guys, I know 2 pi over 3, 4 pi over 3. What am I going to make the bounds for this region? It'll look a little bit different. Bounds for the area. I wish, because if it was, it'd be so much easier. If I go from 2 pi over 3 to 5 or to 4 pi over 3, first of all, I have to think about my motion. But my motion, guys, these are both positive, which means, especially for the 2 means at 0, 2, at pi over 4, 2, at pi over 2, 2. Do you see the motion? Do you see the motion? So if I was to go from 2 pi over 3 and if I was to go to 4 pi over 3, what am I finding? Out here, and I don't want to find out here. What do I want to find? In there.
Can you just do like the top half and go from?
I could do the top half and then I could multiply by 2. So what would the top half be? If I need to start here, what's my angle here? 0.
0, sorry.
Pi over 6, pi over 4, pi over, right? I'm just going, I'm going, and when am I going to stop? There. Right? Hold on, wait. That's not good.
Can you stop at? No, you can't.
Can I stop? What's going to go on with the other curve if I start at 0? It's going to go up to the intersection. Now hold on, do I want any of that? So I'm going to do an undo. I don't want any of that, but what do I want? Starting at 2 pi over 3, what do I need to add?
Oh,
That's not the circle. What is that?
Triangle?
That's the weird funky, cardioid, I think technically, because it's a little cusp, but you can't quite see it because it has like has a flat end. It got kind of pushed. I don't even know. Okay, but the circle will get me there, but it won't get me here. Now he stops, But then what does it, because it's going to the cardioid, right? But now what's it going to? The circle. Now first of all, Layla brought up a great point. It's symmetric, so couldn't I just theoretically focus on one part? And then say times 2?
Yes.
Okay. How do I do that one part? I know I need to add. What would I do for red?
Integral from 0 to
Careful, what happened? Okay, good. 0 to
pi, or is it, what is it? 2 pi over 3.
2 pi over 3. And then I would plug in my r, which is 2 squared, right? R squared plus green time. Where does green start?
At the intersections of 2 pi
Uh-huh.
to pi.
2 pi of but wait, that only does half, right?
Yes.
Double, I'm good. So do you see how bounds are not always the same? And when it's area inside both, you have to think about, wait, what's this area bounded by? Not him, it's bounded by the circle. I just need the circle, the circle, the circle, the circle, the circle, the circle. Oh, the cardioid, the cardioid, the cardioid, the cardioid. And then I take this and say double time. And when I say double time, I don't know if you need to do this one by hand. Theoretically, would it have been by hand? Haha! No. No, wouldn't have been by hand. Would have been by calculator. And this final answer would have been plug and chug. What was important? Intersections are always important. But at this point, intersection was the end of one region and the beginning of the other. Now I could have technically have gone from negative 2 pi over 3 to 2 pi over 3 for this one and not times 2. And then this one I could have gone from 2 pi over 3 to 4 pi over 3, but probably way easier to start at 0. But I don't know, that's just me. Because 0 and pi should be easy to plug in if we were doing by hand, but we're just plugging into calculator, so either way. Questions?
Hey, before we do this, can you grab it and see how it looks?
Yeah. Yeah, on this one. If it's a calculator. But even if it's not, you could try to get the graph in here. But usually if it's not, to be honest, usually they'll give you a curve. Usually, I don't want to say always, but usually. But if you were to graph this, this could have been one. Remember simul mode? It lets us know how it's moving, how it's going. And I could have plugged in my 2, and I could have plugged in my 3 plus 2 cosine theta. I'm in my radian mode. My window, I'm just going to go 0 to 2 pi because I don't want to limit myself. I want to see as much as I can. And maybe I need to go bigger, maybe 0 to 4 pi or negative 2 pi to 2 pi. Either way. But then I could, in simul mode, I could see, wait, I'm in function mode. No, I'm in function mode. Well, there's 2 pi over 3. And anyway, that doesn't really count. Sorry, Youngji. Didn't mean to waste time. What is that? Does anybody know what this is? What is this? Oh my goodness. Who knew there was this many options? Did you guys know there were that many options? I don't pay attention, I don't think. Okay. Alright, if I was to plug in here, there we go. Then I could say, actually clear it 2, and then I could say 3 plus 2 cosine theta. And when I graph, I'm in simul mode, so I'll see intersection 1. So I'll see this one starts at 0, I don't want that one, starts at 0. I could see it moving. I'm going to go zoom standard just for sake of, I have to keep on going. There we go. I could see 2 pi over 3, and then I can see moving around, and then moving around. So I could see the circle I want 0 to 2 pi over 3, cardioid I want 2 pi over 3 to pi. And then double on the other side. The motion does help a lot. Okay. Guys, we're not gonna go crazy on these ones. You can see they're gonna be AP type questions. And we'll get more practice after spring break on these for sure. I don't think really you guys have anything that's crazy tomorrow, because I'm looking more for the general ideas. Can you take derivatives of parametric? Can you take second derivatives of parametric? Can you figure out with x of t and y of t what like the velocity vector would be, or the speed is the magnitude? Could you go from x prime and go back to x and use the clue to figure out what plus c is? Could you take derivatives and second derivatives of polar? Could you do like maybe area, just area, normal area, like area of one petal or area of the entire thing of polar? Pick the right bounds, put it in the formula right. Area between and area inside both. That's the big things I'm doing tomorrow. Okay, so you have seen some AP questions in your packets. There are some AP questions, but that's not my focus tomorrow. My focus tomorrow is not that you're AP ready, but that you're just foundationally ready. Does that make sense? The difference? Okay. I know we have 10B1. I know we have 10B2. That's pretty much where my notes end. But you guys did get your answer keys, and I do have all the worksheets. Is there anything, like a burning question that you're on, that you got stuck on, that you checked, and you don't know how they got an answer?
Oh, I have
Melissa?
a question just
Yeah.
quickly. What assignment do we have over spring break is just coding?
Oh, yeah, I have the green sheets. I'll go ahead and pass them out today so we don't have to worry about it tomorrow. It's just going to be forever and ever coding. And literally that's it. Because for us, we need to know our tests, we need to know our polar parametric formulas. And then right when we get back, the day we get back, I think I'm going to give you
Does this include?
what I'm doing for Calc AB today and tomorrow is I'm giving them a full AP section of multiple choice. They did non-calculator today, calculator tomorrow. You guys are going to get it right when you get back after the Endeavor quiz. So probably the first day back. We'll do an Endeavor quiz. And then we might do like test corrections on stuff, just kind of seeing where we've been and seeing what mistakes we've made. But then you're going to have a simulation probably like Tuesday and Wednesday when you get back. You're going to have non-calculator multiple choice one class period, calculator multiple choice the next period. Actually, I might change that. Tuesday's a chapel day. Would you guys be against us having our Endeavor quiz on Tuesday instead of Monday?
Yes.
Good? Good. Okay. And especially probably for you too. Endeavor quiz will be on Tuesday if you want to write it on the green sheet. Endeavor quiz. Now it says forevers, but you guys know what to do. It's forevers and endeavors, right? Okay. So the Endeavor quiz will be on Tuesday. So then Tuesday. Yep, forever endeavor. Quiz, not the final. Final will be closer to the actual AP, but quiz from all of your coding. 10 times is 100. 15 times you go up to there for bonus. Remember, you have to read it and say it. Read it and say it. Forever's endeavors. So maybe, right, the first day we get back, we'll do non-calculator multiple choice. No pressure. It's not worth a test grade. I'm just giving you the experience of BC multiple choice. Does that make sense? And then I can grade the Scantron, and then we can look at it in our study. So then Monday when we get back, non-calculator multiple choice. Tuesday, Endeavor quiz. Wednesday, calculator multiple choice. Then you have a feel for BC multiple choice. And then over the next 2 weeks before the Saturday final, or the next week and a half, we'll be going over your multiple choice, kind of answering questions, maybe going topically over some of these that you need to see more AP, especially FRQs on, and have us think through, while also throwing in review along the way. So, and then we have our Saturday final, April 18th, and then we have 2 more weeks until the actual AP. So we'll get a lot of AP review. All right. So over break, your main goal: forevers, endeavors, and organizing your life. So that when you come back, you have notes, chapters 1 through 10. You have notes, chapters 1 through 10, all in order, all ready to go. And you have forevers, endeavors, all copied down so that we can be studying until the AP final and the AP. Note check tomorrow? No, but chapter 10 worksheets are due, but answer keys are in.
Can I get task correction, please?
Task corrections, should have already been turned in. Did you guys not turn in?
You
Is it due
said
tomorrow?
Deciding day.
Just turn it off.
I said before spring break, so
Yeah.
when you finish, just put in folder.
Thanks for reminding me, I will forgot.
No,
Does it
it's
go
the
on
same.
the front, Misty?
Test corrections, just turn in before spring break.
In the front?
Test corrections on front, yeah. Test corrections on front.
No, I don't wanna go to college.
Go where?